In this lesson, we will look at the factor theorem and find zeros of polynomial functions. The factor theorem. Suppose p is a non-zero polynomial. The real number c is a zero of p if and only if x minus c is a factor of p of x. What does this tell us about the example p of x equals x squared plus x minus 12? If we factor p of x, we have factors of x plus 4 and x minus 3. By the factor theorem, if x plus 4 is a factor, then x minus a negative 4 is equivalent to x plus 4, and so we would have a 0 of negative 4. If x minus 3 is a factor, then x equals 3 would be a 0. If we do set p of x equal to 0, we will see that that is in fact true. X equals negative 4 is a 0, and x equals 3 is a 0. The polynomial p of x equals 2x cubed plus 5x squared minus 11x plus 4 has a 0 of 1/2. Find the rest of the real zeros and factor p of x. So we'll use synthetic division here. We'll divide p of x by x minus c, and in this case we'll be dividing by x minus 1/2. If 1/2 is a 0, x minus 1/2 is a factor. If we divide by x minus c, we can see in this case our c will actually equal 1/2, which is the 0 here. So I'll use synthetic division, put my 1/2 in the little square box. I have coefficients of 2, 5, negative 11, and 4. We'll bring down the 2. 1/2 times 2 is 1. 5 plus 1 is 6. 1/2 times 6 is 3. Negative 11 plus 3 is negative 8. 1/2 times negative 8 is negative 4, giving me a remainder of 0 and allowing me to factor my polynomial into x minus 1/2 times 2x squared plus 6x minus 8. 2x squared plus 6x minus 8 factors further into 2 times x squared plus 3x minus 4. And x squared plus 3x minus 4 factors further into x plus 4 times x minus 1. Okay, so here is p of x factored. I can look at p of x and figure out what the zeros are there. I have zeros of 1/2. The factor of x plus 4 will give me a 0 of negative 4. The factor of x minus 1 will give me a 0 of 1. So my zeros are 1/2, negative 4, and 1. Next example, 1 is a 0 of multiplicity 2 for the polynomial p of x equals x to the 4th plus 4x cubed minus 2x squared minus 12x plus 9. Find the rest of the real zeros and factor p of x. Well, let's use our 0 of 1 to factor by x minus 1. The coefficients of p are 1, 4, negative 2, negative 12, and 9. I'll bring down the 1 using synthetic division. 1 times 1 is 1. 4 plus 1 is 5. 1 times 5 is 5. Negative 2 plus 5 is 3. 1 times 3 is 3. Negative 12 plus 3 is negative 9. 1 times negative 9 is negative 9. And 9 plus negative 9 is a remainder of 0. So that's good. So we have factored p of x into x minus 1 times x cubed plus 5x squared plus 3x minus 9. Okay, I'm told that 1 is a 0 of multiplicity 2. That means that I should be able to get another factor of x minus 1 out of here. And I'll just use this polynomial x cubed plus 5x squared plus 3x minus 9 to factor x minus 1 out of. So I'll have 1 and coefficients of 1, 5, 3, and negative 9. Bring down the 1. 1 times 1 is 1. 5 plus 1 is 6. 1 times 6 is 6. 3 plus 6 is 9, and 1 times 9 is 9, giving me again a remainder of 0. So I factored the polynomial of p of x further into x minus 1 times x minus 1 times x squared plus 6x plus 9. And I've run out of room here, so we'll need to go on to another clean sheet here. Okay, so p of x equals x minus 1 squared times x squared plus 6x plus 9. X squared plus 6x plus 9 factors into x plus 3 squared. So I end up with a factored polynomial p of x minus 1 squared times x plus 3 squared. And this gives me zeros of x equals 1 is a zero of multiplicity 2, as we were given in the problem. X equals negative 3 is a zero of multiplicity 2 as well. Okay, next let's create a polynomial p with the characteristics. The solutions to p of x equals 0 are x equals plus or minus 1 and x equals 2. Okay, well, I'm just going to start working on this polynomial p of x, and I'm going to, if x equals 1 is a 0, then I know I'll have a factor of x minus 1. If x equals negative 1 is a 0, I know I'll have a factor of x plus 1. And if x equals 2 is a 0, I will have a factor of x minus 2. Okay, so let's look at our next characteristic of the polynomial. The leading term is 3x to the 4th. Well, I'm just going to throw a 3 out here in front. And what I'm missing here is I will need to have another x here. I have 3 x's, so if I multiplied out this polynomial, I would have 3x cubed plus some other stuff. But let's see what our next requirement is. The point 2, 0 is a local minimum on the graph. Well, let's sketch a graph here, just a brief graph. And let's put my zeros on here. I have a 0 of negative 1, a 0 of 1, and a 0 of 2. Okay, and if the point 2, 0 is a local minimum, that means my curve will touch the graph at that point but not cross through. Okay, so that means that x minus 2 should have a multiplicity of 2. Let's double check to make sure that works. Our leading term is 3x to the 4th, so our graph should have behavior similar to y equals x squared on the ends. And so let's go ahead and just draw a quick sketch here. I can see that I will be passing through my graph at the zeros of negative 1 and 1. So the graph would look like this. Looks like it works. So I have found my polynomial p of x to be equal to 3 times x minus 1 times x plus 1 times x minus 2 squared. Try on your own. Negative 2 is a 0 of multiplicity 2 for the polynomial p of x equals x to the 4th plus 4x cubed plus 3x squared minus 4x minus 4. Find the rest of the real zeros and factor p of x.